and pull up the screen. Okay, so what I've done is created a range of different types of problems that are intended to sort of cover all the different skills, and some of them I've grouped in one place. So this is all semi-annual coupon bonds. And what I've done is set them up so that we've got one that's asking you for a price, one that's asking you for yield to maturity, and one that's asking you for N. So it's sort of getting you to think in all those different directions at one time.
Excuse me, Professor.
Yes, right.
Will this slide be put on the questrom tour after we finish the class today?
Yes, that's where you're the lucky section, because it gets posted as soon as you're done.
Okay, thank you.
So it is on Question Tools right now.
Oh, okay, thank you.
So I've been on this one sort of every minute or so giving you one of the answers, but I'm going to give you a moment to look at these, and if you didn't get that number, see if you can reverse engineer it and figure out what should have happened, and then I'm going to show you the calculator inputs. All right, so for this one, the future value is 10,000. The payment is 480. N is 8. I is 3. And you solve for present value. For this one, future value is 1,000. Payment is 39. PV is, sorry, clean that up. PV is minus 960. And N is 16. Give me 1 sec to shut this door. You solve for I. And when you solve for I, you get 4.25 and you have to multiply it by 2. And for the last one, and this last one is the one that I think I've gotten the most emails about this kind of problem in this overall sort of genre. Face value is 1,000. Coupon, the payment is 43. I is 2.7. Present value is negative 1162. You solve for N, and when you solve for N, you're going to get 12. That is 12 6-month periods. So you have to divide it by 2 to get 6 years. So those are the inputs. If you didn't get the same answers, compare what you've got written down for your inputs with those. And if you have any questions about them, let's talk about it. All right, everyone? Thumbs up? We good? All right. So the next one is one of these zero coupon bond problems where you figure out the price at 2 different times and the return between them.
Excuse me.
Yes.
I have a question. Will there be problems asking for return on our investment expressed as an APR?
So in one like this, your APR and your EAR will be the same because
Okay.
it's not broken down into months or quarters or any other period.
Okay. Thank you.
So what I'm going to do on this is give you the price, the second price when you sell it. So you can check that is 88.82. And the calculator inputs for that are future value is 100 and is 5 because the first one there were 8 years left. So 3 years later, there are 5 years left. I is 2.4. Price is the present value. So now what you've got is at the beginning, you buy a bond and you pay $84.50 for it. 3 years later, you sell it for $88.82. And there's two ways that you can find the annual interest rate. So one is that you could say present value is 84.50, future value is 88.82, N is 3, solve for I. The other thing you could do is say 88.82 divided by 84.50. When you do that, you get 1.051, but that's a 3-year return. So you have to take it to the 1/3 power and subtract 1. But either way, you get 1.68. So you're doing it the way that works best for you. At this point, you're doing the keystrokes in the way that works for you. And I'm just showing you both in case you did it the other way. So these problems, and this is, this could have said, what's your annual return? Or it could have said APR. What's happening here is that when you have a 1-year rate and there isn't a period that's smaller than a year, then the APR, an APR that's compounded annually is going to equal the EAR. So the last bond problem is a multiple choice that's just meant to get you to think about kind of the concept of what's happening with bond returns. And we can go back and do more of these in the practice exam in the second half of class if you want. This, I took one of the ones in the practice exam and altered it so it's not the same question. So what's happening with this problem is that it's asking you which ones are going to trade at a discount. So the two things it's playing around with then are that a zero coupon bond always trades at a discount. Whenever the coupon is less than the yield to maturity, the bond is going to trade at a discount. So because with a zero coupon bond, the coupon is zero, that's definitely going to be less than the yield to maturity. So these two zero coupon bonds are going to trade at a discount. For B, the coupon is higher than the yield to maturity, so it will trade at a premium. So the answer to this would have been both A and C. One of the other things that that you sometimes see with these zero coupon multiple choice questions, there's one that's in the practice exam, is that if you buy it when the yield to maturity, so let's say the yield to maturity is 7.4%. If it's the same thing when you sell it, then your return will be 7.4%. So if the yield to maturity doesn't change between when you buy it and sell it, that will be your return. So that was one of the other sort of concept multiple choice questions. It's hard to give you concept questions that are fill in the blanks, so we tend to leave those ones as multiple choice. So what we're going to do here is switch to stock. And what I've done for this slide is a number of questions I've gotten have had to do with some of the variations on these problems. So there are a lot of different ways to create a question that uses this one-year model that we started with. So in this one-year model, there is a price at the beginning. There's a dividend and a price that makes up your total amount of cash that you're getting at the first year. And there is a cost of equity that equates those two numbers. So if we give you 3 of those, you can solve for the other one. You also, if we give you 3 of them, you could figure out what the capital gain is going to be. So on this one, we're having you, the first problem has you do the return. The second one has you do price at time 1, and the third one has you do price at time 0. I'll go ahead and try those. So same thing as with the bonds. I'm going to give you another minute or so to figure out how to get there if you didn't get there, and then I'll walk through these. So for this first one, you have $25 here. You have 27 plus $1 plus $1.50 dividend here, which equals $28.50. So this is your present value. This is your future value. N equals 1. And you solve for I. For the second one, at time 0, the value is 10. At time 1, it's going to be $1.05 plus the price at time 1, and R is 20%. So basically what you're going to do is say that this total piece up here has to equal $12 in order for it to be equal in value to the 10. So 12 divided by 1.20 would be 10. So if $1.05 plus P1 equals 12, P1 equals 10.95.
Professor, I got a question.
Yeah.
Is there like a reason that you don't like using the just basic formula? Or are you trying to like highlight the timeline in this? Or are the equations flawed?
I'm highlighting the timeline because why am I highlighting the timeline? What I find is that when people make mistakes, it's because they put the number at the wrong time. So making sure you're clear where the number goes, and the formula is what the formula does is it says that, that price at time 0 equals dividend 1 plus price 1 over 1 plus RE. So that's what we're doing. When I say that if you're going to solve for P1, the way you're going to end up solving for P1 is by multiplying both sides by that. So when I multiplied 10 by 1.2 and said 12 equals dividend plus P1, that's using that formula.
Got it. Thank you.
Sense?
Totally.
Excuse me?
Part of the reason that I had, yeah, Ray, give me a sec. Part of the reason I put all 3 of these on the same page is that one of the things I found is because they tend to be sort of scattered around in the practice exam, just because it's an old exam where they got scattered. People don't really see that it's the same thing. So I'm trying to sort of get you to realize it's all same thing happening. Ray, yes.
Gotcha.
Yeah, I just checked online that realized return can be also presented as just the amount of money you gain in 1 year. So how would we know that the realized return are present as percentage or the exact amount of money when we're in the exam?
So your realized return is what you've ended up making. So actually the more complete answer to Matt's question would be you could have a realized return on a 0 coupon bond too. Whatever your investment is, it's what you got as a return. in the exam, all of the questions in the exam tell you what to express them as. So they'll say, give the answer as a percent or give the answer as a dollar. So
Oh,
where
okay.
that's a bigger
Thank
issue, and this is an important question, is when we talk about capital gain, your capital gain can be the dollar amount that the stock increased, or it can be the percent that the stock increased. And the question will tell you either to give us a dollar or to give us a percent.
Oh, okay. Thank you.
Well,
For
is it
exactly that reason, because there are definitely some questions where if you don't know which we're asking for, either one would be right.
is it common that they would ask for a realized rate of return, or is it common that they would ask for capital gain, or is that undisclosed information?
In this case, it's not really capital gain, it's the realized return on the entire investment.
Okay.
I'm trying to think, it's not that I'm not, it's not a big secret. I'm just trying to think about, I would probably be more likely to use that language when we were talking about a zero coupon bond than stock. We tend to say, what's the, what was the equity cost of capital? There's something about that question that the grammar doesn't work. That first question, if you're saying what was it, you can't really say what was the equity cost of capital. It's sort of an academic issue. So the last one, and I do see one other question there that I will answer in a moment. The last one is asking for the price today. So that's a more straightforward use of the formula. So we know that at the end of the year, we're going to get $15 plus $1.30, which equals $16.30. So the value today is going to be $16.30 divided by 1 plus R, which equals $14.55. All right, so this next one is still looking at those sort of timeline questions where there's no growth. It's just we're giving you the dividends and a final stock price. So for this problem, you have a timeline that has $5 at year one, $68 at year two, and the value is going to be the present value at time zero. So there's 3 different ways that you could do the math. You could use your CFJ key. All of these are totally correct. So what you're doing is you're doing what works best for you. So you could use your CFJ key, and the inputs would be 0, 5, 68. I is 12, and you solve for NPV. You could say that the price equals 5 divided by 1.12 plus 68 divided by 1.12 squared. To Matt's earlier question, that's using the formula. The other thing you could do that a few of you have done when you've sent me emails over the weekend is you could say, okay, I'm going to take my $68, divide it by 1.12 and bring me back to year one. I'll actually do the math to show you that, which would be $60.71, and add it to the $5 and take that back to time zero. So any one of those is completely correct. They're actually all doing the same thing. So now we're going to move into things that involve growth and return on investment and things like that. So this first one, you have income at year one, you have the information to calculate the growth, and you use the growth to figure out the earnings at year two. So I'll give you a moment to think about this one, and then I'll walk over it with you. So for this one, we have earnings per share in the first year of $30. And we're going to use the growth rate to determine what the second year earnings per share is going to be. So what we need to do is get the growth rate. So growth is going to equal the percent that we reinvest times the return on investment. 20% is the return that we get on money that we invest in the company. And the reinvestment percent, if we're paying a $12 dividend, if you remember this little diagram, your net income either gets paid as a dividend or it gets kept in the company. So for this one, The income is 30. The dividend is 12. So what's left over to retain is 18. We need to know what percent got retained. So 18 divided by 30 times 20% equals 12%. So we're going to take our $30 earnings per share, increase it by 12%, and you get $33.60. Any questions on that? Yes, 18 is being reinvested in the company, but you want to know the percent. Whoops, sorry. You want to know the percent of the earnings that are being reinvested. So you take the 18 and divide it by the earnings, and you get 60%. The other thing you could do, it actually ends up being the same math, but it's a different way of thinking, is you could say we're investing $18. We're going to get a 20% return on it. So you say, okay, what's my 20% return on $18? And what you're going to get is $3.60. So you add $3.60 to your $30 and you get $33.60. All right, so this next slide has two different versions on asking what the ROI is, what the return on investments is. So these are two, there are a lot of different problems that end up saying what is the return on new investments. And this is like trying to give you both categories of problems on the same slide. So the first one is using the growth formula. So we know the growth is 8%. If the dividend payout is 30%, then the retention is 70%. So we only have one variable left. We can solve for ROI, and it's 11.4%. And the second one is going to end up being a two-part problem. So we're going to need that growth formula to find the return on investments. But we don't know the growth. So we need to find it. So we're going to have to back up and use the fact that we know the price and say the price is going to equal the dividend divided by R minus G. So when you use this, you can solve for G equals 9.5%. So now we can come down here and say that 9.5%, now we know what G is, equals, if you're paying $1.50 dividend, it means you're retaining $4.50 times ROI. And now we can solve for ROI.
Professor,
Good with that? Yes.
did you use the top row for that second question?
I don't think so. No.
I was just looking because on the first
I'm
doc,
thinking about it. What were you thinking?
I was thinking of when you're given the price at time 0 and price at time 1 and the dividend, given those three things, you can just put that in the top row and solve for I.
Right, but you
Yeah.
don't have a price at time 1 here.
Ah, that's right. That's time.
Yeah, this is your deal. Once you move into using the perpetuity formulas, you can't do, you're doing something different. All right, one last problem. So this one's harder. The goal on those other ones just was to break all the material out into the underlying concepts so that we would cover all the concepts. And when we get to, when you all give me questions you want to work on in the practice exam, we'll probably go back to doing some harder things. But the goal of this one is to sort of pull it all together. Andrew, yes.
I thought about the top row question, and I was trying to figure out a way, to do it. So I think on the previous slide, right, if your stock price at time 0 was $20, right, and you know that the equity cost of capital is 17, so you can find what P1 is, right, by just growing it 17%, and then subtracting the dividend. So then you have P0 and P1. And then you're right, if you put N in for 1 and solve for I over YR, you get G right from there. But it seems a lot more complicated to do than so. Using the formula
That's a
is
lot more keystrokes.
it is a lot more. I was just trying to figure out a way to use the top row, but in case you were as interested in playing around with the calculator as me, that I just figured out that's one way to do it.
So you have to kind of understand the concept of what's going on with the relationship between the stock prices too. But yes, it is possible, but not necessarily. Usually when you all ask if you can use this top row, it's because you're looking for an easier way to do it. I don't think
It's definitely not efficient.
I don't think that's an easier way.
Yeah, no, it is not.
All right. So I'm going to give you, treat this as a 3-minute problem. I'm just going to sit back and give you 3 minutes to work on it. Then I'm going to give you the answer, and then I'm going to talk about how to do it. And then we'll take a break. And then we'll do any problems you want to do from the practice exams. Give everyone another minute to figure that out. All right, so what we have going on here is our earnings per share next year in year one. So one of the things we try to do is make sure we're making it clear when next year is. So in this first year here, our earnings per share are $20. At year 4, they're going to pay 25% of their earnings at the end of year 4. So we need to find the dividend at year 4, which is going to be a 25% dividend. So that means 1, 2, 3. It's going to grow 3 times, and it's going to grow at 15% up through year 4. So to find the earnings in year 4, 1.15 to the 3rd power times 20 is $30.42. So our earnings in year 4 are going to be $30.42. Our dividend is 25% of that. So 7.604. It's not very legible. So now what we're going to do is we're going to take that time 4 dividend and bring it back to time 3. 7.604 divided by R minus G, because the growth rate slowed to 5%. So the value at year 3 is going to be $58.49. And we're going to take that number and bring it back to time 0. So the easiest way to do that is to make your future value 58.49. N is 3 because this is at time 3. I is our equity cost of capital. Solve for present value, $35.60. So any questions on that? What I'm going to do is have everybody take a break. You'll get more out of doing more questions if you give your mind a few minutes. Tony is going to come troubleshoot any computer issues. I know of one, but there might be other ones that I don't know about. So any of these problems, what's happening is that you're going to invest at time 0. You're going to sell the bond at a later time. So in order to figure out what the return is, you need to find the price at both of those times. So your first project is to just treat it as 2 different bond price problems. So in this case, just to make it a little bit more straightforward and fast for class, I gave you the first price. The second price, because it's 3 years later, you're now going to have 5 years to maturity instead of 8. So N is going to be 5. Yield to maturity is going to be 2.4. Future value is going to be 100. And your price is going to be $88.82. So once you have that, then what you're going to do is say, okay, for my purposes, from my perspective as an investor, this is what I invested at the beginning. So this was my present value. This is what I got at the end. So that's my future value. I held this investment for 3 years. So N is going to be 3. And then you solve for I, and that'll give you the I for each year.
Yeah, I just did it again. I got it. So basically, if you just find the price when there's 5 years left, then you'll get that, and then you can just put that into future value, present value. So
Exactly.
all right, sounds good.
All right, so 21 is the next request. So for this problem, a couple of things to point out about it. You're going to have 20,000 every 6 months. So that is an annuity. You also are going to get 10,000 today. But in order to use your calculator, in order to use the top row of keys on your calculator to calculate the annuity, you're going to be calculating the present value of the annuity. So you can't use the present value key for the 10,000 because you're using it to get the present value of the annuity. But what you can do is say, I'm going to get an annuity that has a present value, and then I'm going to add my 10,000 today, and that will be my total. So for the annuity, whoops. Our payment is going to be 20,000. There are there's 2 payments per year. So for 10 years, N is going to be 20. I, 1.055 to the 1/2 power minus 1. Is 2.71. So when we solve for the present value of this annuity, we're going to get 305,595. Then we add our 10,000. And you get 105,595. Yes.
I just have a question. So I don't know why, but I clear my calculator. I do 1.05 to the 1/2, and I get 1.0247, not 271. Which is, I don't know why.
Because it's 5.5.
Oh,
not
5.5. Yeah, all right, my bad.
There you
Sorry.
go. I didn't answer you right away because I thought I heard you say that, but I thought I would actually look at it first. So while I have it open, 23 is another kind of a problem that thinks sort of concepts about zero coupon bonds. So in this one, when we buy the bond, our yield to maturity is 6.3. When we sell it, it's 6.3. So that gets back to what I was saying earlier today. If you buy it and sell it when the yield to maturity doesn't change, then your return on your investment is going to be that yield to maturity. When you buy and sell a zero coupon bond, the price you sell it at is always going to be the higher than the price you buy it at. If you think about the formula, as we get closer to maturity, N is getting smaller. When N gets smaller, there's an inverse relationship with the price. The price is going to get higher. And C isn't true because you don't need to know the price. You can figure out the answer to A from the fact that the yield was 6.3 both when you bought it and when you sold it. Tommy, let me look at the slide. Give me a second. Answer this question here. So the two key things here are that you need to find out how much you owe. And once you know how much you owe, and we'll come back to that, if you borrowed 10,000, you subtract what you repay, and you're left with what you owe. So this number, the amount that you've repaid, is going to be the number that fills in there. So the way you find out what you owe is it's going to be the present value of the remaining payments. So the first thing you need to do is find the payment. So we'll go back to the beginning of the loan. The present value was 10,000. The loan was a 4-year loan and it had monthly payments. So N is 48. APR was 4.8. So 4.8 divided by 12 is I, and we're going to solve for payment. So our payment is $229.39. And now we're going to find the present value when there are 30 payments left, because it was a 48 payment loan. It started 18 months ago, which means there's 30 left now. So change N to 30, leave everything else the same. And when you solve for present value, you'll get that.
Yeah, I got it. Thanks. It's a tough problem though. A lot going on.
Well, don't spend all night working on it, only because there's not going to be a lot of stuff from the old midterm, but
It should be like more equity than anything else, right?
and bonds
And bonds. Okay.
and earnings. So does anybody else have any others they want to do?
All right. So actually, I just want to like write out the steps. So first thing you do is find the payment. And then you find how much you owe by putting in the amount of months you have left.
Right.
And then you just subtract that from the total loan.
And that tells you how much you've repaid.
Okay. All right. Oh, wait.